As I informed earlier, our today's podcast will be by Vinodkumar Saxena because he has to leave for some work at about 10:45. I told him we'll definitely relieve you before 10:40, and we'll have our other agenda afterwards. uh, in a short, I would like to introduce Vinodji. Vinodji basically from North India, but born and brought up in Pune, and uh, he after completing his BSc and MBA, he worked for 11, 12 years in different capacities in Pune and Bombay, including the defense, plastic industry, then garments and pharmaceuticals. In 1992, he shifted to Bangalore, and more than 2, 3 decades he worked in pharmaceutical as well as one German multinational company. And now he works as a consultant to corporates, mainly in the foreign trade. He has a passion for saving water and saving energy, and he has done some experiments. Accidentally, I saw an old mail by him where he has narrated his work in these two fields. So, after a long gap, after almost 8 or 10 years, I again contacted him on phone, and I thought he will be a good person to tell us his story of success. So luckily he agreed. So today he has to leave early, so we'll give chance to him, and afterwards we'll have our regular agenda. Over to Vinod Kumarji. Please keep your camera on so that this podcast will be more interesting.
Yeah. I was born and brought up in Pune. The place where I stayed, we always had a water problem, right? From my childhood, I can remember. We always had to store water to see that day to day we had to store water. We were staying on the first floor of a house. Every day we had to take water buckets wise and fill up and store it up. We never had a water pressure to come to the first floor also at that time. So I always felt, the water was very essential. And even if we are sick or anything, we had to do that. We had no choice at all. So when I moved out of Pune, I moved to Bombay where, okay, those things were better there. But somehow when I came to Bangalore, again we had the same situations here. Water was scarce, water supply was poor, and we also I had moved into my wife's house and there were a lot of things we had to do it on this water management. So gradually I started doing it, seeing that it had a proper overhead tank, proper underground tank and all those things. After some time, when we wanted to reconstruct our house because my wife's house had become old and we had to do before it becomes spoiled, we wanted to reconstruct it. So during reconstruction in 2003 when we started, my first thing I told my family was, I'm going to do a water management system where we'll be saving water. And I say I'm not going to do any technologies as such. It's going to be simple methods of what I had learned in school of what is called as filtration, decantation, sedimentation. These are the things which are taught to us in school, experimented to us. So I realized that these things can be done in a big way, in a simple house. So when I did the construction, and we also planned to have a construction done in such a way that we let out our house to tenants to stay. And we didn't want to have a regular tenant as a family. We wanted that we'll make it like a hostel for girls because we didn't have any other close by. In our area, there are not many good hostels for girls to stay. So we said we're very specific. There are a lot of boys hostels, but we never found any good girls hostel to stay because one of my friends' daughter had come, and that time I realized what type of girls hostel were there in very bad shape, and girls were forced to stay there. So we said no, we'll go through a lot of improvements in what we are going to do. So when I constructed, I designed it in such a way that I collect all my water which is coming from bathrooms, washing machines and from the kitchen waste into a separate tank. I collected the water in that tank, I pump it up into an overhead tank and I collect it to all the flush tank outlets in my building. So in that way, I was at that time getting from water supply department, I used to get around 80 to 90,000 liters of water this way. And the same water, if I would have not used for wastewater, I have not used for flushing, I would have to use for another 80,000, 90,000 liters of water for the toilet purpose. So we said this wastewater can be easily used. And I started doing that. Also, along with that, I said we had to have a good rainwater harvesting system to recharge the groundwater tables, and so that my borewell is also always full with water. My borewell is just around 145 feet, and people are surprised how come I have a borewell at 145 feet in Bangalore, where in all places in Bangalore where you go, borewells are more than 800 to 1000 feet minimum. This is the situation in Bangalore today. Today at 145 feet, I am getting good water, which is as good as the water supplied by the water supply board. Quality, the TDS, everything is almost the same. So this is the thing which I did, and I'm finding it, I feel so nice that I am able to save so much of water on everything, and this didn't cost me much. I'll tell you, just the extra cost which I had to incur was having an underground tank for this wastewater, an overhead tank for a wastewater. I had to do a separate pipeline for all this thing, and over a period of time, I have recovered during the last 20 years. I have recovered this entire water. Now, in water charges, with the extra charges for this construction purpose, I have recovered it multiple times. It's not been, there's been no issues. And people have complained, people have always questioned to me, do you get smell? I said, I don't get the smell. Do you get will not get, people will get affected by it. I said, it's a closed loop system where nobody touches that water, so there's no question of any people getting affected by this water at all. So I have seen it. At the most, what I do is periodically add little alum to that wastewater tank so that whatever little sediments which come, the dust which comes along with your washing and all those things, they start settling down. And another one thing I started doing is every 3 months I clean up these tanks. I clean up even my other regular water, pure water tanks also. Every 6 months I clear them. But this tank I clear it up every 3 months. So that if there is any contamination or anything, microorganism growth might happen inadvertently or not, I see that it is not there. So this is how my system is working. And I am able to save almost around some say 80,000 to 90,000 liters of water per month. This has been my biggest success in this. Besides this, I also realized the power problems in Bangalore. Power problems is very high, power rates are very high. I didn't want to incur their expenses. I said I'll install a system where I can save power. So what I did is I installed a solar hot water system. Initially I did a 300 liters. I realized it is not sufficient. Then I did increase the capacity to 800 liters. Now today using this 800 liters solar hot water system, I have eliminated all the geysers in my house. No one is using a geyser in my house. There are about 25 people staying there in my house. We know that nobody uses a geyser at all. We get hot water almost 365 days. This is the situation here, and my power supply has drastically reduced. Also, one more thing I did, I realized this the power consumption with this using incandescent lamps or CFL lamps and all those things. I changed everything into LEDs, and besides that, also the ceiling fans. You now have the normal ceiling fans which consume almost 78 watts of power, irrespective of the speed that you run at. I use what is called a new technology fans called as BLDCs or brushless direct current motor fans. These fans have a very low power consumption. They give the same output of air and all those things. At the lowest speed, it consumes just 5 watts of power. At the maximum speed, it consumes about some 28 watts of power. So it gives you tremendous saving of power. You can adjust the speeds, and even the fans are made in such a way that after a certain time, it automatically goes down to the lowest speed after 5-6 hours of running. So I am saving there also power. Using these techniques and all those things, I realized it that once upon a time, which my water electric consumption used to be around some 1200 to 1300 units, it came down drastically to around 625 units. And this I monitored for almost about 5-6 months. Then I went for putting an on-grid solar system. I didn't want to go for I wanted to go for an off-grid, but I realized off-grid solar systems, lighting systems are going to be cumbersome because using batteries is a little dangerous. So all those things, I didn't want to go for that. I said, let me have this on-grid solar system where I generate around 40 units of power per day, out of which around some 20 units I am consuming only around 20 units, and the balance 20 units is being transferred to the electricity board in close to that grid. So there is a saving as well as there is an earning for me also. So I am not paying bills for the last 4 years, electric bill. Similarly, I also introduced a rainwater harvesting system. I just did nothing. I just made the slope of my terrace in such a way that all water came to one point and made an outlet which I put in a small underground tank where I didn't concrete the bottom. I just left the bottom as such. So that the water used to automatically seep down whatever it is there. I never had any flooding at all. Even in spite of the heavy rain sometimes which happen in Bangalore, people said, their rainwater tanks got flooded off and all those things. I never had that thing. But the seepage from my rainwater tank is so fast that within 2 to 3 hours, 80% of the water gets seeps down into the ground and charges the groundwater tables. So this is what I have been doing. There have been technologies which are there which I can utilize it for even purifying the grey water and all those things. But I don't have the space. I have got a very small plot of house where I have managed to put all these things into these things. I didn't have the space for doing that. Otherwise, I would have experimented out for doing that. I know there are technologies which are very eco-friendly and green type technologies for purifying water. I've seen it, but I couldn't do that because I don't have the space. I'm still trying to figure out how I can make it a miniature type of thing. I'm still trying to figure it out with some persons who are doing this technology on a big scale. I'm trying to ask them how to make it on a small scale and what flow I should have and all those things. I'm trying to work with those people. Once it works out, I'll do that purifying even that water also, so that even the grey water tank, which is sometimes I have got surplus, I can use it for my recharging the groundwater tables once again. So all the water which goes out from my house is only the water which goes out from my sewage outlets. There's no water which goes out from any of the other things. So this is how I have been doing it for the last more than 20 years. So this is what, and I have had no problems at all so far. This is what, in short, I can give. This is the explanation I can give for what all my things which are there.
Thank you, Vinodji. Very crisp and very sharp, but very nice innovations you have done in your own house. Now over to other members. You can have some questions.
I will always say, if anyone of us in Bangalore, you can just visit my house. You can come and have a look. A lot of people have come and seen it. I have seen people who have started doing this work also in their house in a small way. Some have been, some they have done it, and some of them, even people from outstations also came in to see the place when they were visiting Bangalore. And they came and saw my place, and they said it's a good innovative thing that they will implement it when they build their own houses and all those things.
Vinodji, I was very much fascinated with your DC fans. I would like to know whether it belongs to one Basil Electronics company. Which company you have these DC fans?
There is a company called the brand name is Gorilla Fans. If you just Google search the Gorilla Fans, you will come to know they are the first person. They are the first people in India to introduce these things. Now all the other companies, all these fan manufacturing companies, also gradually switching over to this BLDC fans because they save a tremendous amount of power. You just Google search Gorilla Fans.
Gorilla.
That's the brand name. Gorilla.
Okay. Because
this is a company in Bombay, at New Bombay. They have got this manufacturing facility there.
Okay. We tried this one Basil Electronics. They supplied these fans to our Madras office as well as even in Rameshwaram. Only problem was whenever there were clouds, these fans were switching off.
Were they working on a solar lighting system?
Yeah. We are trying to have solar also along with that. Yeah.
Yeah, because solar, the thing is, the power generation gradually reduces up when there is heavy clouds and all those things, because the radiation, light and all those things is diminished considerably. So, but this fans I use it on my regular thing itself. Now, since I've got it on grid, so most of my power fans are working on my solar power only. It's only when my on because it's on grid. Only when my when I need more power, that time the best electric board supply comes into me because I am having surplus power. So most of the time I am not using the electricity power from their electricity board. It's only at night I have to use the electric supply from the electricity board. Otherwise, I don't have to use power during the day. It automatically uses my solar power only.
Very good, but actually,
Even if you use this BLDC fans and your regular electric supply coming, I am telling you, you'll be saving a lot of this power from these fans compared to the conventional fans.
no. So my next question is why they are not becoming popular when so much saving is there?
No, it is coming now. Now just see, it is becoming popular now. It is becoming popular now. This company was a startup by IIT students who finished their course and they had during the project they developed these BLDC fans and they started their own company. They didn't join anywhere else. They started their own company like this. And gradually now people have started, okay, they are competing against the big names. You take Godrej, you take, I'm telling you, you take Crompton, you take Usha fans, they are the big people who never bothered about it because most of our industrialists are such, they don't bother about trying to invest into new technologies. Unless until they are really threatened. Till they are threatened, they don't bother about it because they know our demand is always going to be there. So now you see most of these big companies also advertising that BLDC fans now.
Oh, very good. The Prakashji, actually, even government of India also is having in mind that they should switch over to DC supply, and there were some experiments are going on in Rajasthan. But there was some dispute between the scientists whether it should be 24 volt DC or 12 volt or all that. Will you be able to throw some more light on that?
Pranam to all. Thank you. First of all, my sincere gratitude to Saxena ji for such a comprehensive and great presentation, and how individual efforts can make a great impact on energy conservation as well as sustainably living in a metropole like Bangalore. Two things about this. DC fans and DC light is not a new thing. These are in vogue since last, when initially from the time of Thomson itself, there was a debate that whether we should have alternating current or DC current based systems. That is not a new thing. All the solar photovoltaic system in where they are off grid mode, their fans are always invariably DC fans, and lighting systems are also DC. That is the moment we start looking for the grid, because the advantage of the alternating current is that you can go for the far locations and the losses are not that high. You don't require wiring and other things of that nature which is required for the direct current. That is the thing. Once a system is linked to the grid, then if you are generating some electricity, it has to be first converted into alternating current. Then and only then you will pass it to the grid. That is there. Yes. And right. All the systems which are linked to your supply line are based on the alternating systems. The moment you put a DC fan there, then that alternating current has first to be converted into direct current, and thereafter you use it. And the way you explained it means that the losses which are there in converting DC to AC, because solar photovoltaic is DC, it has to be converted into AC to feed into the grid. Secondly, again from grid AC, you have to use into DC, and then and only then the fans work for the DC based current fans. So I'll sum up it like this: DC fans are, yes, I fully agree that DC fans have started becoming more and more popular. Primarily, they are based on the PMG concept, that is called permanent magnetic generator, whereby the variable speed can work for a while in a good way with the least electricity consumption. And there is a niche market always there, but they have never been in the mainstream industry so far, insofar as the fans are concerned. I was going through an article a few days back that the big companies are also creating and they are separate divisions to promote this DC fence now. And you rightly mentioned that these things are getting popular, but my understanding goes there are certain technical issues or I don't know whether the cost economics or other things which still are yet to be resolved so that they become at par with the AC based this electricity fence. So another point which I will like to mention about the presentation, that when you mentioned that ki daytime you use your electricity and night and others you use the grid electricity, perhaps the system does not work like this. The moment you are in the grid means everything goes in the ocean. Whatsoever you generate, it goes in the grid, and you are always getting electricity from the grid. So, and you get, there is a concept called net metering, that how
Yeah.
much electricity you consumed and how much electricity you generated.
Yes,
But
that's what I have it.
yeah, but there is no separation as such,
There's no
because you,
separation, correct. There's no
yeah,
separation, you're right.
it is you are pouring some water in a bucket and thereafter taking water from the bucket. There is
Correct.
no separate glass or separate things which is reserved for that electricity to be consumed in house also. It is
Yes.
electron, it gets mixed, and thereafter no separation. All
Yes,
the moment
correct.
you
You're
get.
right, sir.
Eh? So that was my observation. I thought that to bring little clarity on that, ki how much you
Right.
generate and how much you consume, it is a net balancing only, nothing
Yeah,
more than
it's a
that.
net balancing. What you're saying is true, sir. It's a net balancing.
Yeah, it is net balancing.
Because any layman would always like to see the net balancing. He doesn't go into the technicalities of how the things work.
Yeah.
Finally, in the layman will always see what is the net balancing. He gets into it.
So that is anyway very commendable and very useful. And so far as respected Basdevji's query about the DC fence is concerned, I have this much information only, but there must be people who understand it better, that why it is not being mainstreamed at a very faster pace than that it is at present. So there will be certainly some technical issues that I do understand. If economics is favorable, if cost is favorable, if output is better, then certainly you should pick up. There are no two opinions about it. Thank you very much. Pranam.
Now, I have seen one thing. I would just like to add one thing because I have bought these fans. I have not faced any problems for the last more than 15 years since this DC fan. I have used on all. I have bought 22 DC fans like this in my house. Even my son's apartment, which I bought also, for there also I used my DC fans for the last 2 years. There's been no problems at all. No problems at all. In fact, as I said, the power consumption, irrespective of the speed that is there, that is one of the biggest advantages. You even at the maximum speed on a DC fan, you are consuming just 28 watts of power, whereas the conventional AC fan, ceiling fan, consumes around 78 watts of power. So it's
Now,
almost
perhaps this Bureau of Energy Efficiency body under Government of India has come up with this rating of the fence. And there
yeah.
was, I remember, there was a program which was supported by Global Environment Facility in India also with some grant, whereby they were promoting some star rated fans where the energy consumption at a maximum is about 30 watts or less than that. One professor at IIT Chennai, Professor Ashok Jhunjhunwala, perhaps many of us know his name. He was
Right.
always advocating that how much DC current at what voltage has to be there, and instead of 120 volt, 220 volts, he was advocating that it should be lesser. Sometime it was 48 or something. Volts of the direct current should be permitted for the household consumption. That was another concept going on. But let me put it this way, that there are merits and some limitations of each of the systems, whether we are in this system or another system.
Yeah,
Maybe
yeah.
some
Everyone has its merits and demerits, sir. I agree with you.
yeah.
There could be some demerits also which I have not come across so far.
But
For
this
me,
is
the
really
economic,
great to listen that they are working very well at your premises, means that certainly it is really a very robust kind of situation. That's very good. And I would request you, if there are some visuals also while you make it postcard, perhaps for the Sridharji and others to look at, some visuals can also be incorporated in this podcast so that it becomes more effective that way. Thank you
I
very much.
have shared, regarding my water thing, I have shared one line diagrams with Mr. Vasudev.
Yeah, yeah. No, but this is a very good suggestion. Afterwards, thoda आप, you can send your visuals with the fan running, and it will be more interesting. It will empower our team also to make podcast more interesting and more live.
I'll just show you the fan. Just a minute.
Very good.
Go ahead, sir.
Yeah.
Can you see it now? My fans
Yeah,
running in the
very good.
background.
Very good. Very good. Nice.
Yeah,
Incidentally,
I can control the speed also with a remotes also. The speed is controlled by the remotes. It doesn't require conventional fans. They have that regulators. Here the regulation is done by a remote.
Okay. Very good. Saxena ji, incidentally, our Prakash ji, Maithani ji looks like your brother. He also has similar mustaches like you. प्रकाश जी थोड़ा ऑन कीजिए आपका कैमरा. So what I'm saying, everybody will appreciate. Yeah. आपके भाई लगते हैं कि नहीं?
After a certain age, all look the same. I'll put it this way.
Okay. Thanks.
Another one thing I would like to add also, there's something about the refrigerators also. I had a no-frost refrigerator in the past. It was consuming so much of power. Then I realized it why. I always used to find. Then I checked up with some people who are experts in energy thing, who are experts in AC and all the things. They said no frost refrigerators. They use power for cooling. At the same time, they use power for melting of the ice that is being formed. So the power consumption is high only in the no frost refrigerators is because of that. So I immediately changed over from the no frost refrigerator to a DC, direct cooling one. And I am saying that there is a tremendous saving of power also there because of that.
Very good.
It is a little inconvenience that you have to keep on every 10 days or something. You have to defrost and the defrosting also is such nowadays that the moment that water that is melted off, it goes on at the back where the compressors and all are there, and it cools off there. The compressors generate the heat, so that water keeps on falling down. It just evaporates there. So there is no question of even trying to, your tray getting filled up with water, then you have to take out and do it. So all these inconveniences have been removed when the new ways of which the refrigerators are being made nowadays.
Very good. Valjepan ji, you can ask question.
Yeah. Okay. Sir, so thanks for this presentation. My only question is, in your place, do you have the water levels with high hardness?
No, water levels are absolutely, I can drink directly from that pipe. I don't have to do anything at all.
No. See, my question is slightly different. I understand if it is rainwater, the hardness level is not a problem. And even if it is a municipal water, probably in Bangalore, since you get Kaveri, you may not have. But I'm asking in other cases wherein you have any other problems with hardness.
My borewell water also, I got it tested once. They said it is almost as good as a Kaveri water. You can directly drink it.
Okay.
And there are places where people have gone to 800 feet, 1000 feet and all. There they get a lot of hard water with a lot of other elements which are coming. That's why they use their RO afterwards. And the RO is one of the biggest, you can say, wastage of water. It purify out of 1 liter, you get only 250 ml of pure drinking water out of it, out of which we will divide of all the minerals that are necessary.
That's true. That's right. But then, if you remember, in Bangalore, like we had a severe drought 2 years back, right? 1 or 2 years back. That time, the rainwater, we would not have depended on it, and even the borewell would have gone down severely.
Because the problem, I'll tell you, most of the rainwater which is there, which is happening, why the borewell levels are going down. It is because people are using the rainwater directly. See, we have water to an extent of 75% we say is covered with water. But we don't know that it is, one thing to understand is only 2% of that 75% of water is fit for human consumption or animal consumption. The rest of the water is not used, is of no use at all to us. It's only 2% of the water, of the 75% of the water available on earth is suitable for human consumption or animal consumption. This is one of the facts which people don't understand, and that is why in the rainwater harvesting system they very clearly say minimum 30% to 35% of the rainwater should go for recharging your groundwater tables. People don't do that. People store the rainwater and use it for the day-to-day use. You use how many months in rainwater you have? You have rainwater for just 2 months or 3 months or maximum 4 months. What about the rest of the year? So you are not recharging your groundwater tables at all. Unless until you recharge the groundwater tables, your life sustenance is going to go down very badly. Because life under the crust is the biggest life which is sustaining us, which we don't understand.
Any other question? Last question we can take because afterwards Vinodkumar has to go for some meeting. 1 or 2 questions if anything are there. Okay, I think there is no question.
Okay, thank you very much.
Thank you, Vinodkumar Saxena ji. Definitely I will visit your house when I come to Bangalore.
Definitely, sir. You're welcome. All are welcome to my house anytime to see these things.
Very good. Thanks a lot. Thanks a lot.
Okay then, okay. Thank you.
After editing this podcast, we'll send a copy to you.
Okay then, okay. Thank you very much, sir.
Welcome.
Okay.